final project, I did a little bit more research on the role of localizers and VOR navigation in the cockpit. So, as you can see here, this is a case where we need to use them as the plane's going through the clouds. You have to have some other way of navigating the aircraft through uh, clouds or fog and things like that. So, VOR is a VHF omnidirectional range, and it's an antenna that's ground-based, and the airplanes receive the signals from that antenna. It's only for horizontal navigation. There's no altitude information that the VOR sends. The instrument that pilots read in the cockpit is the CDI, or the course deviation indicator, and most airplanes have some way of reading that in the cockpit. It's mainly for en route navigation and some non-precision approaches. So as we get closer to the runway, like you saw in the previous slide, you wouldn't be using a VOR for navigation usually. The other kind of radio navigation that's also in the VHF frequency is a localizer, and a localizer is also in with ILSs as well, which is an instrument landing system, which uses both a localizer and a glide slope. And those are precision approaches, and those give both vertical and horizontal indication or navigation. They're also where the VOR, you can set a particular course and choose what direction you're going. A localizer and an ILS only transmit one direction, and so they don't have that omni function to them. So in the pictures below, you can see the lower one is a picture of the localizer antenna, and the top one is a picture of the glide slope antenna, and those two together make up an ILS system. The way that we read these signals in the cockpit is either a CDI or an HSI. So a CDI or course deviation indicator, those are the two on top, and those will give you your position relative to the course. They don't give any heading information, so if you can see down at the bottom left corner, there's the OBS, which is the Omni Bearing Selector, and that is able to set what direction or radial is what we call it to the particular station that you're going to. So right there, there's flags on it, but that would be the 360 or the 0 radial. And that just tells us the course. It tells us what direction from that we are. So if we look now to the right, that's also another type of CDI. It doesn't have the glide slope information on it, but you can see that it's also set to north. And the dot, which is like the airplane, is off to the right side, which means it's to the east of that north course. However, we could be pointing any direction. We could be pointing south, it doesn't really show it. It also has the to from flag, which shows that the VOR would be behind that the airplane symbol. Next is a HSI, or horizontal situation indicator. This is generally preferred by pilots and mechanics and aircraft operators because it gives a little bit better situational awareness. Instead of having just the course, we set the course on the yellow arrow, and then the airplane is still the location. However, it also gives us heading information, so the direction that the top white line or orange line on the right side is pointing would be the direction that we're actually flying. So this makes intercepting courses a lot easier, and it combines two instruments into one. So if you look on the right HSI, on the lower right HSI, there it shows us as north of that east course. It also has glide slope information, which is GS, and then those little tick marks on the side show your that's where the glide slope is, and then the white dash is where the airplane is, so that would show that we're below the glide slope. So VOR operations, I think of it as working like a lighthouse. So you can see the animation on the top left shows that there's a non-directional ping, which is the green, and that happens every time the signal heads north. And then there's a directional ping, which is the blue circle, and the airplane times the difference between the lighthouse non-directional ping and then the directional ping, and the distance between those gives them the radial from the station. So if they're both about the same, it's about north. If they're equally apart, it's about south. And then on the diagram to the left, we can see what the OBS actually shows as the aircraft moves across the course. So right here, you can see that it is now moving to the right. Well, it's centered at the moment, but as it moves, we're going to the right, and you can see the changes on the OBS. The rotation is at 30 hertz, and also it's VHF frequency, so 108 megahertz up to 117.95 megahertz are the ranges for those VORs and ILSs. Next, we have the localizer and ILS operation. So this is, again, both horizontal and vertical. And instead of having those different frequencies that move, this just has two different, slightly different frequencies uh, that are transmitted from the localizer, and they make these two lobes that you can see on the top uh, right diagram there. And so the instrument just picks up which one it's getting more of and is able to find the center line of the runway. Usually they're about 2.5 degrees of accuracy, and the same thing happens for the glide slope, except instead of being lateral, it's vertical. And you can see kind of a demonstration of that in that animation in the bottom left corner there, where it starts above the glide slope and then descends on the glide slope. And you also see the different changes that happen to the CDI indicator as the aircraft flies through the course. These are not radio selectable, so unlike a VOR where you can choose what direction from the VOR, this is just one direction, whatever the direction the runway is, and that's somewhat for safety, and you're only ever going to approach the runway in one direction, so there's no real point in having a selectable localizer. Some supplemental instruments that go along with this are DME, or distance measuring equipment. It does basically what it says it does. It measures the slant range distance. So that's just the direct distance from the aircraft. So you can see on the diagram on the top right that distance is going to be have some error to it based on how far away you are, and those are usually associated with VORs. They can be standalone as well. Next is a non-directional beacon. Those are their own type of radar navigation. However, they can be used in coordination with ILSs to give you different locations on the approach. And then all the way to the left are the marker beacons, which also give you a location down the localizer. So there's outer, which is blue. That's usually about 1,500 feet over the ground on the ILS. The middle marker is usually about minimums, or the lowest that an aircraft can fly before it has to break out of the clouds. And then the inner marker is usually right before the end of the runway. You can also see the way that it works. So there's a 75 megahertz receiver, and then it filters out the different tones so that there's only one antenna needed to get all three of those different markers. And by what frequency is going through that antenna, it's able to determine which marker beacon you're over the top of. Some errors and failures that you may have. So on the aircraft, if the antenna was to break for some reason, or there was one of the wires that went to the antenna was broken, that could obviously give you a complete navigation failure. And you can see here a couple different types of antennas on the screen there, and that is they're usually at about a right angle, a dipole antenna, and that's to give good navigation in 360 degrees from the antenna. There's some line of sight obstructions, so if you're at low altitude, as we know, the Earth is curved, so if you're too far away from the station, there could be Earth in between you and the station, and you might not be able to receive the antenna. Altitude is a big factor. If you're too low, you might not be able to see it. However, also if you're too high, you can't see it. And then also down in the bottom left, you see what's called the cone of confusion. So when you're right over the top of the VOR, that's kind of exaggerated for what the VOR would really be like, but you can't really determine your location when you're right over the top, because you're never going to fly right over the top of it, so the CDI needle will swing to one or the other side. And then obviously you can have a ground-based failure where the station itself fails for some reason and isn't usable. There are some accuracy checks that have to be done on aircraft VOR equipment. So there's a VOT, which is a VOR test facility, and those are on the ground, and you set the VOR to the 180 radial, or the OBS, to the 180 radial, and you get a 2 indication, and that means that you've passed that check, or you're within 4 degrees of it. A dual VOR check is where you set both VORs to the same station, and you make sure they're within 4 degrees of each other. An airborne check is just with a single VOR, but there's in some publications you can find where those areas are, and when you're over that area, if you're within 6 degrees of what it says the radial should be, then you've passed the check. And the ground check is the same thing, except it's on the field somewhere, and those have a slightly smaller tolerance, which is 4 degrees. Aircraft maintenance actions. There's removal and installation. You can't actually open the instrument without a repairman's license. Antenna installation, and you might have to run the wires between the antennas. And my works cited.